All right, Ozarka here. This is going to be a video all about functions, and basically we're going to be doing what's listed here in the section objectives right here. Determine whether a relation is a function. A relation, just the root term of that is related. So you're basically going to be seeing two numbers that are related to each other, and when they're related, they could be related in a way that's called a function. We're going to go into more detail of what a function is in this video. Number two, it says determine the domain and range of a function. So domain is basically all the possible x values that you can have for a function. The range is all the possible y values or outputs that you can have on a function. So x is always the input, y is the output. We'll talk about more about that later in the video. Number three, it says use function notation and evaluate functions. So we're going to be evaluating functions at certain points using function notation, which if you've heard of that before, it usually goes with like an f of x or a g of x or whatever the name of the function is of x. So x is the input usually. Number four, it says interpret graphs of functions. So we're going to be looking at graphs of functions and then getting certain information from those graphs. And then number five, evaluate difference quotients, which is going to be extremely important when you take calculus because the derivative is basically built upon the idea of a difference quotient. So we're going to be doing those five objectives throughout this video. By the end of the video, you should be able to do all of those things. And if not, then make sure you ask questions during class to kind of get that squared away. The video is meant to help, but if you do actually need extra help outside of the video, you're definitely going to want to ask. All right, so relations, it says right here, a relation is a set of ordered pairs. So you can think of it like, again, the root term of relations is related. There's these ordered pairs. So there's these two numbers that are somehow related to each other, and they're called relations. And sometimes they're just related by they're just together, okay? And then sometimes they're related by some kind of an equation or something like that. But either way, that's just two numbers that are kind of together. Any set of ordered pairs automatically relates the set of the first coordinates to the set of the second coordinates. The domain of a relation is the set of the first coordinates. The range is the set of the second. Okay, another way of thinking about domain and range is that domain is all the possible x values, where range is all the possible y values. X is the input, y is the output in this way. All right, next it says consider the relation defined by 0, 1, 1, 2, 2, 3, 3, 4, 4, 5. What is the domain? So the domain, I'm just gonna write a D here with a colon, is basically all of the first values, all those x values. It's always gonna be x, y. So in this case, it's gonna be 0, 1, 2, 3, and 4. So that's essentially all of the first numbers that are in those relations. And then the range is all the second values. So we're going to have a 1, a 2, a 3, a 4, and a 5. And we're going to use curly braces to, open and close basically those sets of numbers there. Can you think of a formula that describes this relation? So what you can do, because again, I said the domain is the x, you can basically say that y is equal to whatever x is plus 1. So in a way, you can kind of use that formula, which basically shows the exact same thing as these set of ordered pairs there, where y is equal to x plus 1. All right, on to the next example. It says consider the relation defined by 1, 1, 1, 2, 1, 3, and 1, 4. What is the domain? So this time the domain, use some curly braces again, it's just going to be 1. Okay, so if you notice 1 is the first number on each of them. You don't need to write it more than once. 1 is in the domain. That's the domain. The range is going to be all those second numbers. So 1, 2, 3, 4. So 1, 2, 3, 4 is the range for this one. Now, one thing that I want you to notice between number 1 and number 2 here is, what's the formula for number 2? The number 1 specifically asks, can you think of a formula that describes the relation? Y equals x plus 1. That makes sense. But what would be a formula that could describe the relation between the domain and range here for number 2? Okay, you only have one input is 1, and then you're getting a 2 out of it, a 3 out of it, a 4 out of it, and a 1 out of it. So what would be how can you make an equation for that? And the moral of the story is you can't. You cannot actually make an equation on this. Therefore, it's not a function. We kind of talked about that in the very beginning of we're going to go into more detail about what a function is. In this case, it shows that you cannot make a formula. If you cannot make a formula, it's not a function. We're going to go in more detail with that in just a second, but let's keep going on this to make sure this makes a little bit more sense. The graph of a relation involves real numbers in the collection of all ordered pairs plotted in the rectangular Cartesian coordinate system. So the XY coordinate plane, where basically you can graph those onto it. And it's called graph because you're basically making the domain and range, those X and Y values, you're going to make them graphically. So they just call it a graph when you actually, plot the points of a relation. So it says, look back at previous examples, sketch the graphs of the relations. Okay, so this first one, it's just 0, 1, 2, 3, 4 for the domain, and then 1, 2, 3, 4, 5 for the range. So I'm just gonna plot those on the XY coordinate plane, like 0, 1. I'm gonna go 0 for the Y, which is just 0 is just this line basically right here for the Y, and then 0 for the X would be this line right here. So it's gonna be 0 for the X first and 1 for the Y, so it's gonna be up here, 0, 1. Okay, the next one we're going to plot is 1, 2. So we're going to go x is 1, y is 2. So if you notice the x is 1 right here, the y is 2, and we're going to just, wherever they intersect, those two coordinates, you're going to put a little dot there. Next, 2, 3. So 2 and 3 right here. 3, 4, 4, 5. So it makes this nice, I don't know, almost a line in a way. You can't really connect the dots on this necessarily because we don't actually know for sure what's going on in between. We only know what's going on at x equals 0, 1, 2, 3, and 4. We know the y's for that. Okay, now I'm going to do the exact same thing on that second set of data, that second relation, basically the 1, 1, 1, 2, 1, 3, 1, 4 coordinates. So 1, 1 would be right here, 1, 2 would be right here, 1, 3 would be right here, and 1, 4 would be right there. Okay, now if you notice, you cannot make a formula for those orange dots that I just basically plotted right there. And that's actually one of the signs that it's not a function. Okay, the red is a function. You can make a formula for it, y equals x plus 1. But the orange, you cannot make a formula for that. It also stacks on top of that x equals 1. X is equal to 1 for all of those. You cannot make a formula for that because it does not pass what's called the vertical line test. We're going to go over that in more detail in just a second. But whenever they stack vertically like that, there is no formula you can make for that function, for that relation. Therefore, it's not actually a function. All right, so now let's go in a deeper dive into what a function is. A function is a relation in which every element of the domain is paired with exactly one element of the range. So that means every x only has one y. And if you notice, the one that I said was not a function, number 2 basically, it's all of the x's are 1. But really, you get different y's out of them. But really, you should, if you have one x, you should only be able to get one y out of it. But we have 4 different y's with the same x. That's why it's not actually a function, because a function has every element of the domain is paired with just one of the range, not multiple. And again, when you do have a relation that has a certain element in the domain and has multiple outputs, multiple elements in the range, then it's going to stack up on top of itself like that and not pass what's called the vertical line test, which we're going to go over in a second. Equivalently, a function is a relation in which no two distinct ordered pairs have the same first coordinates. The second coordinates can be reused, but the first cannot. We're going to kind of show examples of that as well. Functions and relations are typically defined in one of 4 ways: a table or a list, a graph, so we kind of already graphed it, a formula, I kind of showed you a formula before, and then a verbal description. Now the next thing here is the vertical line test. We were kind of just talking about that a second ago. So the vertical line test: if a relation can be graphed in a rectangular coordinate system, the relation is a function if and only if no vertical line can pass through the graph more than once. So if you make a vertical line and you could pass through multiple points on that same graph, then it is not a function, because they should not stack vertically like that. If even one vertical line intersects the graph 2 or more times, the graph is not a graph of a function, and you'll never be able to create a formula for it. Onward we go. Function notation. In this course, the most common way in which a function will be defined is by a formula or an equation. In functional notation, or just function notation, we name the function rather than the dependent variable and describe the relation. For example, f of x equals 2x. So this is basically the y value here, f of x, and then this is the formula that you would need, x being the input. And it says here x can be any number. How you would say this, f of x, this right here, it's pronounced f of x, not fx. Please do not call it that. It's like kind of a pet peeve of mine. Math is a language. You are going to want to become as fluent in it as you possibly can, so that f parentheses x end parentheses, that it's pronounced f of x. Okay, it kind of says it right here, f of x. Or f at x, but usually that's not used. It's f of x. F of x is the value of the function named f when there's a certain input value x. Okay. So I'm going to highlight there, and to kind of make that make more sense, we're actually going to do some example problems, graph some stuff out, so hopefully this makes more sense. But just think of f of x as y in this case, because primarily that's what it's going to be. Once you get to other math classes that are a little bit more advanced than this one, like calculus, you'll actually see that y is going to be equal to other functions, not just f of x. It can be equal to f prime of x or f double prime of x, which is basically the derivative. Again, you're going to go over that when you take calculus, so that'll make more sense. But just know for this class, if you ever see f of x, you can just kind of think of it as a y for this class. All right, next it says sketch the graph of the function defined above. So the function defined above, that's the f of x is equal to 2x. Okay, so I'm going to sketch a graph of this. To sketch a graph of this, we are going to need some points. I'm actually going to make an xy table, so this is a little bit more organized. And I'm going to pick some easy values like, I don't know, 0, 1, -1, and I'm going to plug those in as my x values here. So 0 times x, the y is going to be 0. And again, this could actually say y is equal to f of x. It's going to be the same thing. Okay, f of 1 is going to be 2, f of -1 is going to be -2. And what I can do now is plot those x's and y's and then just connect the dots essentially. So we have something like this, and then we can just connect the dots. And that's basically a sketch of the graph of the function defined right there. All right, this next one, it says let f of x equal 2x squared plus 1 for any real number x. evaluate f of 5. So f of 5 means that anywhere there's an x, you're just going to replace it with a 5. So f of x, now it's f of 5. Instead of 2x squared, it's going to be 2 times 5 squared, I'm going to put that in parentheses, plus 1. Okay, so wherever there was an x, I basically replaced it with a 5. Okay, well 5 squared is 25 times 2 is 50 plus 1 is 51. So evaluate f of 5, that's this part right here, evaluate f of 5, I just found it right there to be 51. What does the graph of f look like? How do we know f defines a function? So one thing we can do here is we're gonna make another xy table, something like that. We're gonna put in, let's see here, I don't know, 0 is a good one to plug in, and then things that are around that 0 is good. So let's put in 0, you're gonna get a 1. You plug in 1, you're gonna get 3. Plug in -1, you also get 3, because this is a parabola. Let's put in 2 and -2 as well. Okay, when you plug in 2, you're gonna get 4 times 2 is 8 plus 1 is 9. -2, again, you're gonna get 4, positive 4 that is, times 2 plus 1, again, you're gonna get 9. Okay, so you'll see the symmetry on this problem, and the graph ends up looking like that because of it. Okay, so if you actually look, 0, 1 is plotted right there, 1, 3 is plotted right there, -1, and so on. You can kind of see all the values there. And based on just looking at the graph, you can see that it's a function because it passes the vertical line test. So we can say f passes the vertical line test. All right, next it says, what is the domain and range of the function g of x is equal to x squared? So now you'll notice that the function is not f of x in this case, it's g of x, which is totally okay. You can use whatever letter you want. A lot of times you'll see f, but then the second one you'll probably see is g, probably because it's the next letter in the alphabet, but doesn't matter. All right, it says, what is the domain and range? The domain is any value that you can plug in to this formula. And there's no value you can't plug in to this formula, because you can take any number and you can square it. Okay, so therefore it's any number between -infinity and +infinity. That's what the domain would be for this one. Okay, we're gonna go over another example after this where it shows like certain values that you cannot plug in. Namely, you cannot do, like you can't divide by 0. So if there's an x value that causes a division by 0, you can't use it. You can't do the square root of a negative, all right? Because then you'd have imaginary numbers. So this one does not have any division and doesn't have any square root, so you don't have to worry about that. The range, one way of doing the range is just think of the smallest possible value that you can have on this, like as an output. So if I put like a -infinity in this and it's squared, it would be +infinity. Okay, if you plugged in 0, you would get 0 on it. So 0 is actually the smallest number you can have. Since it's included in the domain, we're going to put brackets there. Okay, and then it's also going to infinity. This goes up forever. This is going to be a parabola if you graphed it. And you end up having -infinity to infinity for the domain. The range is 0 to infinity. You can't go into the negatives, so you'll notice there's no negative in the y part of this, the range. All right, next it says, what is the domain of the function capital F of x? Okay, so they're changing it up a little bit here with the capital F of x. It's still just a function though. What is the domain? It's all x values that you can use to actually get an output. The thing is, we have some division here. We have an x minus 7 factor and a 5x plus 3 factor. And these cannot be equal to 0, because if they were equal to 0, then you'd be dividing by 0. So basically, x minus 7 cannot equal 0, as well as 5x plus 3 cannot equal 0. So what you can do is solve these, and we're going to add 7 to both sides. X cannot be equal to 7. We're going to subtract 3, divide by 5 here. X cannot be equal to -3/5. So it says, what is the domain? The domain is x cannot be equal to 7, and x cannot be equal to -3/5. That would be part of the domain. It could be any other number, but it can't be those. Now, you could write this in interval notation if you really wanted. So we're basically going from -infinity, and then eventually the first hiccup we're going to have is the -3/5. You cannot have -3/5 because you'd be dividing by 0. So writing this interval notation would look like that. Union, now we're going to go from 3/5, and then it stops at 7. And then another union, and then it's 7 to infinity. Okay, but that purple, that stuff that I just wrote in purple, is completely equivalent to what I wrote in blue there. 2 ways of writing basically the exact same thing. It's just a lot easier to write the blue than that whole purple thing. But either way, they can both be used as the answer. All right, the next one. What is the domain of the function h of x? So you'll see f's, you'll see g's, you'll also see h's. Square root of x minus 5. Well, you cannot do the square root of a negative. You can do the square root of 0, but you have to be positive. So that means x minus 5 has to be greater than or equal to 0. So if we just solve this inequality right here, the x minus 5 is greater than or equal to 0, we'll actually get the answer for the domain on this, because you cannot take the square root of a negative number. but you could take the square root of a positive number or 0. So that means x minus 5 has to be positive or equal to 0. That's basically what it says right here. We're going to add 5 on both sides. And the answer for this is x has to be greater than or equal to 5. Okay, if you graphed this out, you would see that x can only be greater than or equal to 5 on a coordinate plane. It cannot be less than 5. Because if it was, you'd be doing the square root of a negative. Another way of writing this is with interval notation. The answer can be from 5 inclusive to infinity. Okay, so the yellow means the same thing as the orange here. Again, it's just a different way of writing it. Number 9, it says let f of x equal x squared minus x minus 6. Does this actually define a function? And the answer would be yes. Okay, any x you put in there, you're going to get a y value out, and you're only going to get one y value because it's a formula. You're not going to get multiple y values if you plug in one number. That's impossible. If you plug in 1, you're going to get one specific number. If you plug in 2, you're going to get one specific number. You're only going to get one number out for any x value that you plug in. What is the domain? It would be from negative infinity to positive infinity. It is important to note that you have to use parentheses with the infinite symbols. You can't use brackets because you can't include infinity because you can't actually get to infinity. All right, the next thing, evaluate f of 1. So we're going to plug 1 into this equation here, which means you're going to get 1 squared minus 1, which is 0, minus 6 is negative 6. So that's going to be negative 6 for f of 1. Then it says find the x and y intercept. So for the x-intercept, we're going to set y equal to 0, which in this case is the f of x. So we're going to set x squared minus 6 equal to 0. So the y is equal to 0 in this case. We can factor this. So it's going to be negative 3 and x plus 2. Set that equal to 0. X equals 3 and x equals negative 2. So that's the x-intercept. The y-intercept is when you set x equal to 0. So we're going to set x equal to 0 and you should get negative 6. So 0 squared minus 0 minus 6 is going to be negative 6 again, and you have the y-intercept. Next it says evaluate f of t. Well, you're just going to put t in wherever there's x's. So it's just going to be t squared minus t minus 6. It's not that complicated. The next one is more complicated. It says evaluate and expand f of t minus 2. So f of t minus 2 is going to be t minus 2 quantity squared minus t minus 2, in parentheses, minus 6. Now it says to expand this. So we literally have to expand this out all the way. I'm going to do it kind of quick just to save some time. Something like that. Okay, combine like terms, t squared doesn't combine with anything. Negative 4t minus t is negative 5t. 4 plus 2 is 6 minus 6 is 0. So the final answer should be this thing right here, t squared minus 5t. All right, number 10, the graph of a function is shown below. Determine the domain and range of f, and also determine the intervals where f is positive and the intervals in which, f of x is positive and in which f of x is negative. Okay, so domain, we'll start with that first. It's all the possible x values. Okay, well the smallest x value is negative 5, inclusive, so it's going to be brackets. The biggest x value is 5, so that's the domain. You can see right here the smallest is negative 5, the biggest is 5. Okay, the range is going to be the smallest y value, which is negative 4, and that's inclusive, all the way up to this value up here, which is 9, so negative 4 to 9 for that one. All right, the next part, determine the intervals on which f of x is positive. Well, it's positive, negative 4 to 0, but you can't actually include the negative 4 and 0 because that's where it's actually equal to 0. We just want where it's positive. So it'd be negative 4 to 0, but you're not including the negative 4 and 0. Union from 3 to 5. Okay, we can include the 5 because it's not equal to 0 there. We cannot include the 3 because it's 0 at 3, not positive. The next thing is, where is f negative? Well, f is negative below the x-axis, so this part right here. So it's going to be negative 5 inclusive to 4, but not including the 4 because it's equal to 0 there. Union, let's see here, from 0 to 3, but we can't include 0 and 3 because they're equal to 0 at 0 and 3. So you have something like that. Number 11, consider the relation whose graph is shown below. I kind of just showed it off to the side just for the sake of space. Let's call it f. Is this a graph of a function? So let's just look at this real quick here. Does it pass the vertical line test? Is there any points that are stacked up on top of each other vertically? The answer is no, so the answer for the question is yes. Is it a function? Yes, because it passes the vertical line test. What is the domain? Okay, so it's all the x's. I'm going to start from the left first. So we have, all right, so we're going to have negative 4, negative 3, and 1. Those are just like separate points. So this point, and this point are all separate. And we're going to union this with negative 2 to 0. That's this part right here, negative 2 to 0. And then we're going to union that with 2 to 4. Inclusive on those, and that's the answer for the domain. The next question, the range, that's just the y values. The smallest y value is -1, inclusive, and then it goes all the way up to 3. So -1's the smallest here and here, the biggest is 3, and it goes through every single point in between, all these y's here. So that's going to include all of these because we're just working our way up. So it's just going to be -1 to 3. Those are the only y values that you can get on this. Next, it says evaluate f of 1. F of 1 would be right here, so it'd just be 2. So I'm going to put the answer to this one right here, 2, and then f of 3 is 0. F of 3.5 is 3.2, 3.4, 3.6, so somewhere like right here. Looks like it's 1.5. F of 1.5 is, there's no point there, so it's just undefined. Okay, there is no point at at x is equal to 1.5, so there's no output, it's just undefined. All right, the x-intercepts and y-intercepts, well, the x-intercepts are going to be at -1 and 3 for the x-intercepts. The y-intercept looks like it's just at 1. Okay, that's not too complicated. 12, it says let f of x equal 2x plus 1, expand and simplify the difference quotient. Okay, this is how I would always do the difference quotient. By the way, the formula for the difference quotient is right here. So we're just basically going to be figuring out this formula for this function right here, the 2x plus 1. First thing I'm going to do is find this part right here that I'm highlighting, f of x plus h. So f of x plus h is equal to 2, instead of 2x, it's going to be 2 times x plus h plus 1. If you notice, I did put it in parentheses. Distribute the 2, and you end up with something like this. Okay. So now what I'm going to do is I'm going to put this orange in the formula up here. So now it's going to be 2x plus 2h plus 1 minus f of x. So my f of x is just 2x plus 1. It was given in the original problem right here. And then I'm going to divide all that by h. Okay, now from here, I'm just going to simplify some stuff. 2x minus 2x cancels, 1 minus 1 cancels, and you get 2h over h. Well, the h's are going to cancel, and you're left with just 2 for this one. All right, the next one, again, we're going to do the same exact thing. Find f of x plus h first, which is going to be x plus h quantity squared minus 3 times x plus h plus 1. Okay, x plus h squared is x squared plus 2hx plus h squared minus 3x minus 3h plus 1. Okay, what we just figured out was basically this part right here. So I'm going to write that in the formula, x squared plus 2xh plus h squared minus 3x minus 3h plus 1. Then you're going to subtract the original equation. So x squared minus 3x plus 1. We're going to divide all of this by h. By h. All right, we're going to do a bunch of simplifying. In this case, the x squared is going to cancel, the negative 3x is going to cancel, and the 1 is going to cancel. By the way, just in case you're keeping score at home, anything where you divide, anything that doesn't have an h in it, you're going to be getting rid of. Okay, so the x squared, the negative 3x, and the plus 1 all cancel out. So if you notice, everything else that's left has an h in it. I'm going to divide out the h's for each of these, and you're going to have 2x for this first one, so that's going to cancel there. It's going to cancel one of these. It's going to cancel this one here. And your final answer is going to be 2x plus h minus 3. It's just a really sloppy h, I apologize. And last but not least, expand and simplify the difference quotient for f of x is equal to 1 over x. So first thing, I'm going to find f of x plus h, which is 1 over x plus h. Don't have to do much on that. And then it's going to be 1 minus x plus h minus 1 over x divided by h. Now it does say expand and simplify. We have a fraction on top of a whole fraction here, which is obviously not what you're going to want to do. It's not fully simplified. So we're going to multiply the top and the bottom here by x, and then I'm going to multiply the top and the bottom here by x plus h. So now if you notice they have common denominators, it's going to be x minus x plus h all over x times x plus h, all divided by h. We're going to simplify some things here. X minus x is going to cancel. Now this h right here is going to cancel with this right here, so it's just 1 over 1. So you're going to have a negative 1 on top over x times x plus h, and that's your final answer for that one. So that's basically the video on functions. We did those 5 section objectives throughout this video, but if you have any questions, if you cannot do those on your own, definitely let me know. We can work on them more in class. All right, I hope that was helpful. If you have any other questions, let me know.